Hi, this is Tom, and welcome to Lesson 24, the variances. What we're going to do is we're going to talk about the variances and how they're calculated, what they mean, and what the differences are. So here's where we're going to begin. So I'm going to begin with the data set. So this is our data set. It's not very fancy. Our data set is going to be the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that's our data set. So what we're going to do now is we're going to do a few things, but this time first let's find the mean. Now, I'm going to give you a little bit more. This is my data set, the numbers 0 through 10, and we're going to make an assumption. We're going to assume assume that this is all possible numbers. All possible numbers. Okay, now they may occur in different frequencies, but these are the only possible numbers that we can have. So let's try this. Let's find the mean. And before we do that, there's two different things. So when we say find the mean, there's two different ones. If I ask for the mean, let's do it this way, of the population, then I'm going to be finding what we call mu. It's the Greek letter mu. And if I say find the mean of the sample, then we're going to be finding x bar, which is the notation we have been using. So mu means that you could sample all possible data set, all possible data. For example, if you were taking the heights of females in the United States, if you found mu, that means you were able to measure every single adult female in the United States, took all of their heights, and then calculated your average. That would be mu. So you can see how mu is a hard number to actually find for real. So what we have to do is use samples as our best representation. So let's just try this today. We're going to first find mu. And we're going to just add up our data, 0 plus 1 plus 2 plus 3 plus 4 plus 5, 6 plus 7 plus 8 plus 9 plus 10. There we go. We're going to add up all of that data. We're going to divide it by the number of values, which is 11. And if I do that, let's see. If I add 0 through 5, that's 15 right there. And then, let's see, if I go 6 and 7, that's 13. Oh, we'll just add it to the 15. That's 28. Plus 8 more is 36. Plus 9 more is 45. Plus 10, that's 55. There we have it. 55 divided by 11. And so the mean mu is 5. Now, here's what we're going to do next. So we're going to randomly select four data values. 4 values. And we'll do this, repeats are allowed. Okay, so my sample set is, let's see, I'm going to take a 0. I don't know why. And we'll also pick a 10. We'll be extreme. 0, a 10, and then oh, I got it. Let's do a repeat. How about a 1 and a 1? So that is my sample data set, and we're going to do the same thing, but this time when we're finding the mean, we're finding x bar, because this is just a little tiny piece of the whole. So I would take 0 and add to that 10 plus 1 plus 1. Let's see, that's going to be, there's 4 values, so that's 12 divided by 4, and so it looks like x bar is 3. X bar is 3. So now we're going to try an exercise. And what we're going to do is we're going to calculate variance. Calculate variance 2 ways. We're going to do it 2 ways. So the first way we're going to do it is 2 ways using, let's see, well, let me write it this way. 2 ways. First way will be using mu, and the second one will be using x bar. All right, and just in case you've forgotten, remember the variance in general. Variance is we take the data, so we take the data x, and we subtract the mean. We'll just put mean here because we're going to do it for both of those, and then we square it. Add all those up and we divide by the number of data. That's the mean. That's how we calculate variance in general. So we're going to do this 2 ways. The first one is called the population method. The population variance. And in the population variance, we use this lowercase squiggly circle. It's called sigma. Population sigma squared. That's how we read that. That's sigma. Sigma is the letter and the 2 is the squared. So sigma squared. And sigma squared equals, specifically, it's the sum of the data minus mu squared divided by n. And then we're going to find what's called the uncorrected, we'll see why, uncorrected sample variance. And we represent that with the lowercase n with a little subscript of an n and also squared. So it's Sn squared. That's how we'll say it. We'll say Sn squared. And Sn squared is found as the sum of, we take the data, we subtract x bar this time, and we square it, divide it by n. All right, so let's do this. We're going to calculate this both ways now. So remember, from up above, x bar is 3, mu is 5. So here we go. So we're going to calculate this. So sigma squared for my sample data set is going to be, we had a 0, so I'm going to take a 0 minus mu, which was 5, squared, plus 10 minus 5 squared, plus we have a 1 minus 5 squared, plus we had another 1 minus 5 squared. We'll add all those up. We have 4 data values, so we'll divide by, oops, not n. N in this case is 4. So let's finish this out. So that's 0 minus 5 is negative 5. We square it to get 25. 10 minus 5 is 5. We square it to get 25. 1 minus 5 is negative 4. We square it to get 16, and then another 16. So we're going to add all of that up. We'll divide that by 4. So that's going to be 50 and 32. That's going to be 82 divided by 4. That's going to be, I think that's 20.2. Nope, just 20.5. There it is, 20.5. Let me correct that. 20.5. Now let's do this side by side here, but now let's do it for Sn squared, the uncorrected sample variance. So again, we have a 0, but this time we're using x bar, which is 3 squared. Plus, we have another 10 minus 3 squared plus 1 minus 3 squared plus 1 minus 3 squared. And we divide that by 4. So let's see, 0 minus 3 is negative 3. We square it to get a 9. 10 minus 3 is 7. We square that to get a 49. Plus 1 minus 3 is negative 2. Square it to get 4. And then we have another one. We're going to divide that by 4. So 9 plus 49 is 58. 58 plus 4 is 62, plus another 4 would be 66 over 4. And, did I do that right? Let me double check. That's 58 plus, yeah, 66. 66 divided by 4. Let me double check that really quick. 9 plus 40. 49 plus 8. 66. And then we're going to divide that by a number of data, and so this becomes 16.5. 16.5. So here's what is significant about that. What is significant about that is, notice this. Notice that Sn squared is less than sigma squared. And it's a long and lengthy mathematical proof, but what you can actually prove is this is always the case. This is always the case. And so because of that, because we know this, so because we know that Sn squared is, and we'll just use a math symbol here, because we know that it's always less than sigma squared, it is called a biased estimator. And in other words, if we're using it, we'd be knowingly making mistakes. And so we don't want to do that. We don't want to do that. So what we do is this. And this is actually a rather involved math problem, but there's a correction. So there's a correction. Oh, but before I say that, because there's actually a problem here. Because notice this. Realistically, now I'll write this so we have it, is that realistically, sigma squared is impossible. Is impossible because it's based on mu, which is impossible. I mean, we can try. We can get really close to. But in the end, it's mostly a construct. So because of that, calculating sigma squared is really difficult. So what we want to do is, since it's so difficult to do, is we make a correction. We make a correction using what we have, using what we do know. And what we do know is we know x bar. That we know for sure. And the correction is n over n minus 1 times Sn squared. Now, we're not going to make a big deal of this math, but we'll show you the result. So if I take the number n over n minus 1, and I multiply it by Sn squared, well, remember that Sn squared is the sum of x minus x bar squared divided by n. So what happens then, you probably can already see this, is that the n's cancel, and so our final result is the sum of x minus x bar squared divided by n minus 1. And we call this s squared. That's actually a lowercase s. We call that lowercase s squared. And from now on, whenever you have to find the variance of a sample set of data, what you should be finding is s squared. Hope that helps. Thanks for watching.